Hello, everyone, and thank you for joining us today for our Advances in Stormwater Detention Systems Configuration and Design webcast. Today, we will discuss how to design detention systems faster and how to protect stone void space from solids contamination. While everyone is still logging on, we'll take this time to start off with a poll question. Our question is, my go-to caffeine drink of choice for when I need to crank out some work or do a design is soda, espresso, coffee or a latte, an energy drink, or another I don't drink caffeine. We'll take some time now for you to mark your selections, and thank you all for joining us today. Most of you have answered. Thank you. Here are the results. It looks like most people go for coffee when they need to get work done. Before we start today's presentation, we would like to cover a few housekeeping matters that will ensure you have a good experience. We have placed all phones on mute to cut down on background noise and to ensure everyone can hear the presentation. At the conclusion of today's webinar, we will provide information on how to obtain PDH credit for today's presentation. Our webinar today is scheduled to last for 1 hour and will include a question and answer period. If you have a question, please type it in the question box at any time. Today's webinar will be presented by Robert Chapman with special guest Yuya Ishizuka, our Stormwater Design Engineer, available to answer questions. Robert Chapman is the Director of Product and Analytics at Contech. Robert has extensive experience in manufacturing, engineering, marketing, and product development. He has brought numerous products to market in various divisions within Contech using his unique and creative approach. Rob holds a bachelor's degree in mechanical engineering and technology from Purdue University and an MBA from Miami University Oxford School of Business. Yuya has a bachelor's degree in biological systems engineering from Virginia Tech and 6 years of experience with engineers in identifying and designing project-specific solutions in stormwater. Now I'll turn the presentation over to Rob to get us started.
Thanks, Jill. All right, as Jill mentioned, I absolutely love product, and it's been a great last few months here at Contech. As you can see, we're all hyped up on caffeine. We had the caffeine poll question, and we're going to review 2 great new products that have recently released here. And then there's going to be a common theme as you see the slides as we progress, and that's virtual collaboration. It's a really key sticking point that we want you to walk away from this presentation with. The first great product that we're going to touch base on, though, is the all-new Contech DYO, specifically the DYO DS package in that. We're giving engineers faster designability, better deliverables, and have designed a system that makes engineering changes that much easier. The deliverables that you're going to get from the system are going to one-up what's out there and be a game changer for what's needing to be handed off in that next portion of the stormwater design process. They're beautiful, but also very straightforward. Second, we're going to have Yuya review a great new technology that's exclusive to Contech. It's going to protect your design and minimize downstream flooding risk. And best of all, it's an add-on to an already great existing underground stormwater product. I mentioned virtual collaboration. You'll hear that a lot. We have a lot of great collaborators attending this call today. Many engineers have already reached out for us for product tours. We've done it via Teams, via Skype, via Zoom. We've actually designed systems in real time in 3D with contractors, developers, owners, and engineers all on the same call. It's very exciting stuff. So we're going to dive right into DYO DS first. What is DYO DS? Some of you may know, but it's actually our design your own detention system. The name's been around at Contech for almost a decade, but these updates that we have are definitely killer as we see them. Why did we need such a big update though? We need to discuss the pain points that are out there with design and layout software. We all know that they're out there. What do we have? So users need to share login information on a lot of systems that are out there just to give others access to projects and designs that they've done. Worst yet, you may have to recreate something from the ground up just to get to where you need. The engineering change process, it's extremely tedious. Last minute changes to a project, running into utilities on a site, they can be killer and just make the software, the layout process, downright unusable. And then lastly, everyone has their idea of what's intuitive and how you can handle the system. How far are you getting with this DYO design and layout stuff? Are you getting 10% of the way there, 25, 50? Are you lucky in actually getting 75 or 90% of the way there? And then lastly, deliverables. Sometimes they take forever, sometimes they don't come at all. And then who knows what's on them? We're really working to change that, to bring up that next evolution deliverables that we can give to engineers, and engineers can pass those on to others that need them. Our team here at Contech now, it's all internal developers that understand the stormwater industry. We've received a lot of feedback from our legacy system over the years. And this past summer, when we rolled out the new version, the engineering community, contractors, they've all been more than helpful with offering guidance and help and helping them with what they need out of a DYO system. As I mentioned, it's the next generation of underground stormwater design. And to get into what it actually is, it's an all new 2D and 3D design environment that we've done for those users accessing the system. We've also tried to maintain the intuitiveness of keeping things simple when you need to design something. We've added the ability to import your site plans and design right over the top of them, just a simple scale and start designing. Second, fully customizable options. So this has been a big thing in underground storage, being able to do non-rectangular footprints. We offer 2 new design types in the system now. So you can design to your site limitations or a design storage footprint that you need to have, or you can maximize for a given footprint on your site and the system will calculate it automatically for you. We've also included the ability to do variable diameter, detention infiltration, small diameter manifolds, multiple inlets, multiple outlets, knockouts, risers, and then coming soon, internal structures. And what's being powered by all this? Cloud powered. You all hear the word cloud a lot, so everything's in the cloud. What does that mean? Well, these cloud servers are powering everything in the background at 5 times the speed for calculations, 5 times faster than our prior version. And it's not just flinging the stored data out there to save so you can access it later. It's powering our graphics engine. It's powering the CAD, DWG, the storage calculations, and the deliverables that the engineers need to get to that next portion of the process. And finally, here's that word again, virtual collaboration. It is the focus of our stormwater strategy here at Contech for years to come. So we're rolling out the first project collaboration feature in the industry. We're gonna get to that in just a second. So Jill, I believe you have another poll question.
I do, Rob. Here's our second question. My experience with DYO platforms is they typically get you 10% of the way there, 25% of the way there, 50% of the way there, 75% or more of the way there, or they aren't helpful at all. I'll give you some time now to mark your selections. And just a reminder, if you have a question, please type it in the box, and at the end of the presentation, I will ask them aloud. I'll give you a couple more moments to make your selections. Looks like most of you have answered. Thank you. I'll share the results. Looks like 51% say that their DYO platforms get them 50% of the way there.
Okay, well, we got 40 to 50% more to shoot for with what we're going through now then. All right, so we're gonna focus more on this virtual collaboration for a minute here. What really constitutes a virtual collaboration? Is it more than just, hey, hop on a Teams call, hop on a Zoom call, hit me up on Skype? We are really trying to lead the way with virtual collaboration. We're holding virtual brown bags with those that need it. We're meeting with engineers and contractors, much like yourselves. I mentioned designing projects in real time. I have a great example of something that happened just last week. We had an engineer and a contractor where we had a utility issue on site. We actually viewed the design in real time in 3D. We moved some inlets around and we had a new layout drawing before the end of the meeting. That's pretty fantastic for what we're able to do. We have a great feature also that is out there now that you may not know about. It's not intended just for sales. It's extended to our excellent stormwater design team. That's the chat function. We have an expert team of stormwater design engineers behind the scenes that can offer a variety of support, everything all the way up to this new DYODS platform. And then I mentioned this new project collaboration feature, and we're gonna go over that right now. So what is it? It's that button right there, the 3 dots there. You'll see it in a few spots in our DYO system. Share, share, share. Collaboration leads to efficiency. You click on it and you can add others to your projects and design. They're going to get a notification that they've been added to a project and listed as a collaborator. So you can share within your organization, you can share with owners, developers, contractors, even share with Contech's team. And if you take a look below, that's our all new card system. So this is an actual product tour. So we're not, or a product demo rather, we're not going to give you a tour of the whole system, but we've added an all new card system to make projects and design easier. So each project is going to have a card with the title of the project, the total number of designs that are associated, when it was last touched by one of the collaborators, and then the collaborators all listed below with their email access. This is going to improve the efficiency of everything along the chain to make sure that everyone's on the same page. All right, so I believe we have another poll question just to keep everybody on their toes, Jill.
That's right, Rob. Here is our third question, and for those of you that follow Contech on LinkedIn, you should know the answer. Where is the largest underground detention system in North America located? Is it Syracuse, New York, Winter Garden, Florida, Indianapolis, Indiana, Houston, Texas, or La Jolla, California? I'll give you some time now to mark your selections. And don't forget to type your questions in the box, and we'll ask them at the end of the presentation. Looks like most of you have answered. Thank you. Here are the results. It looks like 13% think it's Syracuse, 13% say Winter Garden, Florida, 13% say Indianapolis, 48% say Houston, Texas, and 13% say La Jolla, California, Rob.
All right, well, it is Houston. Interesting that everything else was the same. All right, so we're gonna get right into the thick of things with demo. So what to look out for as I go through this next portion here. We're gonna design 2 systems, one from the ground up. We're gonna recreate a project that we did. And then the other example that we're gonna give is a very early stage deliverable that's really impactful for what you're able to get out of the system. So what to look out for. I mentioned non-standard rectangular design. So you see that stair step system in the top left there. Auto and smart dimensioning, top right there. Move risers, inlets, and stubs. Very easy throughout the system. I mentioned cloud power. It's very fast. Don't take that for granted. And then for the traditionalists out there, we do still offer that same 2D environment, same toolbox and CAD system that's off on the right there. So we're going to get into it. I'm going to pull up the actual system itself right now. I mentioned the all-new CAD card system. I got a few example projects here. So for this actual webcast, we're going to go into this August DYO webcast. I'm the only collaborator here, but if I wanted to add Yuya to here, I could go in and type Yuya's email address. He'll get a notification that I've started some designs here. So diving into here, the first system we're going to do is an actual system we're going to recreate from the ground up based on something that we've done in the past. And that's a system we did in the Pacific Northwest a little over a year ago. And it's a 21,100 cubic foot storage system. And it was done for a high school to preserve a green area on site. And what we're presented with here is the intro to the system. So I haven't done anything here. I just titled it 72-inch green development, and you're presented with a simple here. What I did do though to speed it up is you could see the site plan here, and it's not to scale, but what we could see here is where the existing system is, and then you have the high school there. So we're going to actually scale this and then start designing. So scale site plan, we'll zoom out and we'll find the legend here. Click there and there, and that is 20 feet. There we go. So things look a lot better to scale there. So not every PDF comes in as you want, as everybody knows that's worked with them. So we're actually going to rotate this to be in line with our prior design, negative 90 degrees there. So there you can see the existing system, and then we're going to actually go ahead. We're going to move this up and then start working from the ground up. So I mentioned keeping it simple and intuitive. So system type solid or perforated for detention and infiltration. This system length was 110 foot. See, I already practiced this. 85 foot wide. I mentioned the two design options. We're going to limit to the storage input because we've already gotten numbers that we need to use for other engineers on the project. So 21, 100. This was buried fairly deep for a detention system at 12 feet, and then 4 inches of pavement there. And then we're going to regenerate that. You can see the system getting bigger there. And we do know that it was 72-inch system, so we're going to go and change this from 126 to 72. And then there we go. I'm going to move this so we can see it better. And then we do offer a toggle, so if you want to switch between the traditional view or the actual 3D isometric view, you could do that. Our systems default to bulkheads for efficiency along the whole process, but the system is a little bit older, so it did have 2 manifolds. And in order to do that, in the pipe info, you just click 2 manifolds and then regenerate. And here you can see that it put on that second manifold. There was some structural backfill things that the team had done to get 24-inch spacing. I believe that was the last thing they did before we can start adding risers and T's. So you can see just how perfect that lines up to our existing system. So what I'm going to do now is add an inlet to right here and then just an outlet somewhere over here, just to give the audience an idea of how easy everything is. So first thing I'm going to do is just make sure everything's lined up. And then what we're going to do is get that inlet pipe. And then to do that, our CAD tools are off on the right over there. I believe I'm pointing the right way there. We're going to grab this measuring tool, and we could see that this inlet is 2 foot. So in order to add an inlet to the pipe, you go to the Advanced tab, and that's going to bring up the customization. So our system's been generally used for 2 areas, like full on, we're going to get as many of the risers, stubs, and T's lined up as possible, dimensioning them. And then the next example is just a very generic, we need a deliverable type thing. So I'm going to try and meet halfway with this design. So in order to do that, click on the Advanced section, and then you're going to be presented with a number of options. So you can erase that section, clone it, add a riser stub, knock it out. So I'm going to add a stub to that. And then you could see as I toggle back over here, it placed a default stub right there. So we need to make some adjustments there. I'm going to change this because we know it was 24 inches, 2 foot there, and then we're going to take this 2 foot off the invert, and we're going to update this. There you go. And then I'm going to switch back to 2D mode, and we're going to line this up. So when you click on a piece, you can see you're presented with directional arrows. We're just going to move that to where it needs to go right there. Then we're going to go over here and just add another basic one just to get an idea of how easy it is. So click there, add another stub. We're going to make that 24 inches, and we will take that 2 foot off as well. All right, and then I believe this system had access risers every other piece. So in order to do that, you can actually click on multiple pieces. Just going to do that, that, and that. So we grab those 3 sections of pipe, and then we're going to add a access riser to those. So now you could see exactly where those are. You could drag them around just like I did with the stub there. And then in order to smart dimension stuff, and you can move things around to however you like, traditional CAD tools are off on the right here. You could grab this XX and then go from point to point and then put your dimensions on there. And to make it easier, if you want to view anything without actually seeing the site plan behind, you could actually click off so you could see where you're dimensioning to and everything that's going on behind the scenes, behind your site plan. So I'm going to leave that as is. On this particular one, they did run into some utility issues. And just like adding a riser or a stub, what we're going to do is just go back to the Advanced tab, and I believe it was right in this section here. where they had to knock out a section for a utility pole, and you just go to the knockout. We'll leave it at 5 foot there, and then we'll update everything to make sure that the system automatically puts bulkheads on pieces that have been adjusted for knockouts, T's, and elbows, so it knows where a missing piece needs to be adjusted and make sure that's something that can be manufactured. We offer 3 outputs over here. So this is the traditional PDF file or PDF file, DWG file. So the same thing that you got with our prior system, clicking that's going to export that. New to this is the BIM model. So if you need to bring this into another system, you can get a 3D model of this. And then what's been used for deliverables a lot by the community is this image function. All that it's doing is asking you to essentially stage your system how you want on the site plans, and then show you a snapshot so you can put that into another document for yourself. All right, so that was the hybrid of the 2 types of designs that we're seeing from engineers, contractors out there. We're going to save this and then hit up the next design. So save, I'll go back into my projects. And then this idea was actually brought to us by an engineer out west, I believe, with wanting to be able to use something very early stage to get out for a deliverable to something that they needed to do. And what they actually did is wanted us to be able to design on a Google Maps just to get an idea of where something needed to go. Like I said, early stage deliverables. So I have imported and scaled this site plan already. This project actually existed. It needed a lot of storage, as you can see. And in order to make this easier to see, so to give you an idea of the project, there was a warehouse over here in a high school, and they wanted to avoid putting a pond for safety reasons, green space type of thing, somewhere over in here. And we had this very large 162-inch system that needed to go in there. So what I'm going to do is actually align the site plan to make us better aligned with the road. There we go. So it's going to go right alongside the road there. We're going to move it. And then this system is actually an infiltration system. And to do that, if you caught the initial project there, there's a perforator solid type of system. You can do hybrids if you need. We do have projects like that. But the limiting length that they were given was 630 feet. They had 85 foot of space. And what we did is maximize for a given footprint. So how much storage can we get in here? There was a lot of water requirements. So it was buried pretty deep at 20 foot. And then going into the pipe information, you see the 162-inch pipe, 25 foot in length. This was a single manifold system. The one thing that I do need to change looking at this is it generally in sizes this large, you can get equalizer and smaller diameter manifolds. So I'm going to put one of those on here right now, and we're going to change this manifold to a 60-inch manifold rather than having to fabricate a big 162-inch system. So there we go. So you can see how fast it's working. It's updating storage requirements, giving you the total storage. If you click on calculations, you could see loading, linear foot of pipe, pipe storage, stone storage, total storage, if you had any requirements, and then other calculations that we're trying to fine tune and get everybody exactly what they need from these deliverables. So you can see excavation amounts, pavement amounts if you've chosen to do that, structural backfill, footprint area, and then footprint perimeter. So final system looks like this before I go to the deliverables. I'll pan around. You can see that small diameter manifold that's right there. We switched that up to 60 inches and put it on there. And then if you wanted to add risers, something like this, you'd probably need quite a bit. You could just go through and hit the advanced tab and then put them every certain interval, since this is 600 feet in length. There we go. And we'll just put risers there. The scaling's a bit odd with something this big, but there you can see the manifold with the risers. Not going to go ahead and add a stub, inlets or outlets for time here, because the deliverables are what everybody cares about on this call. So going back to the actual presentation, here are the deliverables. So beautiful. So this is what's included in the email that you're getting from the DYO package. So off to the left there, you see the high school. Don't see the warehouse. I hadn't developed the design for that yet, but you get some very high level stuff that you need for this stage of the project. It's a 162-inch perforated CMP system. Pipe storage is around 450K. Stone storage around 90. You see the total storage, total area, total perimeter. It's a great deliverable. Our SDE team, that is very well received between them and the community. And then off to the right there, your standard CAD file, as much as you dimension it. So if you dimension risers, stubs, tees, elbows, make changes to knockouts, and then start dimensioning them, they will show on this DWG file. We need to get you as far as you want in the process, and you could take it as far as you want. There's a lot of options, but what's presented to you in our toolbox are the intuitiveness that we've talked about. Keep it simple. If you want to get more detailed and get further in the process, you can. The further you get in the process, the further we get. Behind the scenes, there's a lot of servers running, powering this. Like I said, 5 times faster. It's generating these CAD files. It's generating stage storage sheets. It's generating fabrication stuff, should it even go forward. So we have everything as up to date as possible in the system. And then in the bottom right there, a BIM model. So there are other CAD programs that are out there where you can take what's output from the system given to you in an email and use that in those systems. So a rehash of deliverables, just so you could see it in Word rather than the pictures. BIM model, DWG CAD file, design layout, stage storage calculator, and then that really awesome design location on the site plan if you upload that. I will say that we've had some users that have wanted to put multiple underground systems, and all that they've been doing is just saving their design. You could see the other system as a snapshot on it and just design a new system somewhere else in the site. So that wraps up the DYO portion going forward here. We're going to take a look at the next product that we want to review. And I believe we have a poll question, right, Jill?
That's right, Rob. Here's our next question. What stone void percentage do you utilize in design for underground storage? 43% or more, 40 to 43%, 38 to 40%, 36 to 38%, or 35% or less? I'll give you some time now to make your selections. And we have some really great questions coming in, so just a reminder, type your question in the box and I'll ask it at the end, or we'll give you an instant answer if it's something easy. I'll give you a couple more moments to make your selections. Okay, thank you all. Looks like most of you have answered. I'll share the responses now. Looks like 3% say 43% or more, 26% say 40% to 43%, 39% say 38 to 40%, 9% say 36 to 38%, and 22% say 35% or less. So Rob, it looks like most people are using 38 to 40%.
Okay. We do have some conservatives and some optimistic engineers out there. So we're going to touch base on that in a little bit. And what we're going to showcase right now, we're going to show a video of a new product, the add-on that I spoke about for our existing underground detention product. It's an innovation that we've been developing over the last year. Reliable, protects the stone. It's a low-cost add-on to an existing product. And rather than sit here and go over the technicalities of it, make sure your computer audio is on. I don't know if it's going to come through on the phone, but we do have subtitles for those that are not able to do it. 2-minute video. It's going to highlight exactly what the Void Saver is, how it can help, and why it aids in design to protect you long-term, minimize that flooding risk.
Stone void contamination is one of the leading threats to the long-term reliability of underground stormwater detention systems. Contamination from solids can compromise stone void storage before site stabilization and present a compounding downstream flooding risk each year with long-term accumulation. The Void Saver alleviates these problems by containing the majority of storm events within the pipe and only utilizing the stone void storage during infrequent events. As a result, solids are contained within the pipe and not the stone. Here's how it works. Stormwater enters the Void Saver through one or more inlets from the storm sewer system. Unlike traditional chambers and perforated pipe systems that utilize stone void space immediately, the Void Saver delays the use of the stone void storage by storing the vast majority of rainfall events within the pipe. As water fills the system, suspended solids settle in the large internal volume rather than dispersing into the stone, clogging the stone void space and compromising the design. Only during extreme events will the water reach the top of the pipe. At that point, the cleaner water discharges to the surrounding stone backfill through a specially designed stone overflow vent. The screened overflow vent prevents any floatables from leaving the pipe. After the storm subsides, water within the pipe continues discharging, creating differential head pressure between the water within the pipe and water within the stone. This external driving head opens one-way water return valves, allowing the water within the pipe and stone to drain down together. Like conventional pipe systems, inspection and maintenance are easily conducted through large access risers, where trash and sediment can be removed manually or with a vacuum truck. The Void Saver, an innovative, reliable, low-cost solution from Contech Engineered Solutions. To learn more, please visit conteches.com/voidsaver.
All right. Welcome back. Hopefully the video went smooth for everybody that was able to see that. So let's talk about design storage rates. We had a lot of good feedback from who was using what in terms of percentages, but they often don't get thought about as being that important in the industry. The standard 40% number gets thrown around. And we're going to discuss why you shouldn't just default to something. The importance, 25 to as much as 60% of a project for the design storage can reside in the stone. And the national standard seems to be that 40% number. But there's been very few large scale studies. It's been largely, hey, let's take a few samples from a few places, assume that the product meets 100% spec, it's been put in the ground clean, and it's been being maintained for the life of the project. Focusing on the word clean, erosion and sediment controls, improperly followed erosion and sediment controls, they can mimic years of contamination in the stone if you do not account for them. Consistency and quality, so stone A is not necessarily the same as stone A from quarry B. There's variation in stone types, there's variation even within companies. And then long term, we just can't put stuff in the ground and then hope all is well, everything is maintained for 75, 100, 125 years. Long-term sediment contamination is very important. It's going to be a focus of the industry going forward, I can just tell. So moving forward, I mentioned there's been no in-depth study until now. So one was finally conducted, not by Contech, by the way, the source is below, but this is a huge study. It had 41 facilities in the United States with 300 plus washed aggregates. So washed being key there. And what it shows is that 40% is not a given truth. It's still an average that's been communicated. Same aggregates in the study were found to have variation throughout various geographies, even within the same company. And then the biggest bullet from the study, as you can see there, to get 96% reliability in your stone storage design, you really need to consider about 36%. Let's go to another poll question, and we're going to have Yulia is going to take over from here and start talking about why design's at risk right away before you even get to the long-term stuff there.
Sounds good, Rob. Here's our last question of the day. How confident are you in erosion and sediment control on site? Are you totally confident, commonly implemented? often followed but sediment still finds its way downstream, or they are never followed. Are you kidding me? We'll take a couple moments now for you to mark your selections. We have some great questions coming in, so just a reminder, type it in the box, and at the end of the presentation, I will ask them aloud. I'll give you a couple more moments to mark your selections. Okay, thank you all for participating. I'll share the results now. 8% say they're totally confident, 24% say that they're commonly implemented, 55% say they're often followed but sediment still finds its way downstream, and 13% say they never are followed. Are you kidding me?
Awesome. All right. Well, we're going to have Yuya review just that. Let me move it over. And Yuya.
All right. I am doing the webcam check, looks to be on, and the mic check looks to be good. All right. So just wanted to run those two quick checks here. So good morning, everybody. Thank you, Rob, again, and hope everybody in attendance is having an excellent start to your day this morning. So continuing on this discussion, I'd like to talk about a few examples of the potential risk factors that are associated with the concept of stone storage as a whole, and why it's really important to consider its potential long-term impacts for your detention system. So underground detention systems are what's defined as a post-construction B&P, as we all know. And the performance of the system is considered after the system has been successfully installed. But what about before or during the installation phase? And as engineers, contractors, everybody in this industry, I'm sure, is all too familiar. Containing construction sediment in a site is extremely challenging. And whether it's the grading on the site or the weather, as illustrated by the two images that you see on this slide, to the left, it can be potentially very disruptive. So given this, any detention system design that utilizes storage in the stone voids is potentially immediately at risk. In a situation where construction sediment is entering your detention system footprint during the installation, the system has already been compromised before the project site is even open. So this is critical as the valuable void space within the stone gets occluded. This then reduces the storage capacity of your system, which then increases your chances of flooding downstream. And in this slide, there's a few examples of common ENS controls that we see to limit construction sediment, installing temporary measures like silt fences or inlet protections that you see in the images there on the slide. You can plug the system, blocking orifices or any other flow control structures until the site is stabilized. That's important as well. Or you can install pre-treatment system upstream, which is typically recommended for any underground or above ground detention system, such as a hydrodynamic separator. So with that said, still, the possibility of construction sediment generating from the site and then entering your project area, that risk, that possibility is always going to be there, despite our best efforts with the methods that we just discussed. So it's important to consider this in designs. Would I need to consider a factor safety for the construction phase? Or, how much confidence can I place in my storage in the stone voids? These are the type of things that you start asking yourself when you look at a detention system design using stones, the voids in the stone for storage. So what we're going to be talking about next. So we just discussed design risk during installation, but what about after? This is more in tune of what we typically think about as a post-construction B&P. What could be the long-term effects of stone void contamination in terms of the overall storage capacity of your system? So following up on Rob's earlier point, the industry standard for void space storage is 40%, but it was really interesting to see the variety in the poll question earlier. But if I start there at 40%, for instance, is it clear that I get 40% for the system's design service life? There's no doubt that stone voids are prone to buildup of sediment over time, and there's no going back once the voids are occluded, which results in a permanent loss of storage capacity. So with that, the end goal would be to minimize the reliance on your stone storage. And by doing so, you maintain as much of the storage capacity as possible for your system, reducing downstream concerns. So here I have a graph comparing a variety of materials of varying shapes and sizes. From the top, 48-inch diameter CMP, 96-inch diameter CMP, 30-inch chambers, and 60-inch chambers. And given the following situation, say if 20% of your stone voids has been occluded due to sediment buildup over time, how much overall storage of your detention system would be lost permanently? So for 96-inch CMP, we have an estimated 5% loss. Hopefully you can see the numbers on the slide there. For 30-inch chambers, we have 12%, and 48-inch pipe, we have 7%, 60-inch chamber, we have 8%. And one comparison I'd like to highlight here is 96-inch CMP to 30-inch chambers. And you'll note that the loss of overall storage is a little more than double when comparing those two numbers, the 5% and the 12%. And the reason for this is that there's a heavier reliance on stone storage to achieve your total storage for the chambers. And that's indicated by the material to stone ratio that is on the left there. And for instance, 96-inch pipe has an estimated 25% of overall storage achieved with the surrounding stone, compared to 30-inch, which has an estimated 42%. So you see that significantly a higher proportion there with the chambers. And usually this comes down to, you know, additional pipe stone that's needed for the bedding and the cover sections, which results in an increased quantity per vertical cross section. So one thing to consider here is that storage capacity in the material is maintainable. However, storage capacity in the stone, once it gets occluded, is not maintainable. So therefore, providing more storage in the material has significantly less risk for you as a specifier, and ensures the overall storage can be counted on for the long term. So in summary, and given these challenges with stone storage, both during installation and as a post-construction, you know, best managed practice, just as we talked about, you know, how can I specify a detention system with confidence that relies on stone storage, but does not compromise my design? And this is exactly what the Void Saver looks to address. And whatever the service life of your voids would effectively need to match a service life of the material for your system as well. And by limiting the use of stone storage until it is really needed for the peak events, this ensures that you have a detention system designed that you can count on. So to summarize, I've outlined 4 takeaways with features and benefits of a Void Saver design. This just more or less summarizes our discussion here today. First being that, you know, it protects the valuable stone voids from contamination, which then protects the storage capacity, minimizing downstream flooding risk. And if there's one takeaway here from the presentation, it's probably that. Void Saver also leverages the use of stone storage, so that reduces your overall system footprint, which leads to an overall lower material and installation cost. In addition, we didn't talk about this in detail, but another feature is that it doesn't rely on fabrics like geotextiles for pretreatment, so therefore that eliminates the concern of potential clogging and ensures a reliable protection of your voids. And finally, specifically the pipe, there's, you know, easier maintenance access as well for these systems, which reduces your overall long-term maintenance related costs. So with that, Rob, I will turn it back to you.
All right, thanks, Yuya. So we're at 45 minutes here. We're going to get a quick recap and then Q&A that's come through in the chat function. So on the DYO front, it can be a pain, but it doesn't have to. Use technology, collaborate virtually, and then communicate stuff that's a pain for you to the industry out there, and they can make improvements. Deliverables can make or break a project. They can also make the design process that much easier, better deliverables, more efficient. Everybody knows what's going on. And then being able to change those deliverables as you encounter issues on site, utilities, grading issues, etc. Making changes and getting quick redesigns done is key. And then On the new product technology front, consider the number that you use in stone storage. Don't just default to something that has been thrown out there. And then be a leader, make sure sites follow erosion and sediment control. And then as Yulia mentioned, you saw the video, the Void Saver is a great product, a low cost alternative for stuff that's out there. It's going to be able to protect your design for the life of the project and pretty easily maintainable, just like the existing system. So that wraps it up for our end. Jill, you want to hit any of the chat questions if any came through?
Of course, Rob, we've had lots of great questions. Just a reminder, type it in the box and I'll ask it at this time. Our first question is about that large detention project on the intro slide. Can you tell us a little bit about it?
This is going to inflate the Southern California team's head, but that is the Rialto Distribution Fulfillment Center, I believe. It was about 3 million cubic foot of storage, and that actually had 162-inch pipe. And Darwin will be happy to know that his drone videos went to good use.
Thank you, Rob. Our next question is, can you put a catch basin right on top of the pipe similar to the access risers?
Here, you want to grab that one?
Yeah, I can. So yes, it is possible. It is used quite often. So we can fabricate access risers in a variety of different diameters and to meet whatever your catch basin dimensions are. We can suit that need and fit it right on top of a riser.
Thank you, Yuya. Are there any issues with floatables clogging the screen, leaving the Void Saver?
Rob, did you have any input on that one, or?
No, generally sediment's going to fall out on there, and then we do have the option for floatables containment. If there's issues in that, just weir plates will go on the system and work like they traditionally have.
Thank you, Rob. Does the DYO software interface with existing applications like HydroCAD or Civil 3D?
You got that one. You're the HydroCAD person.
I do. So the answer to that is, so basically what DYO DS is ultimately it's a layout design tool. So the storage volume will need to be predetermined by any sort of modeling software like HydroCAD or HydroFlow or whatever that you use. But there is, with the DYO feature, there is a bin model that can be directly exported from your DYO design page. So it is able to design to be accommodating with Civil 3D.
Thank you, Yuya. Is this system available for your chamber and Duramax products?
So the system is also available in Duramax, which is currently in the works, in addition to chambers as well. They're both currently in the works.
And the layout and design process will almost mimic this underground CMP design process to a T when we do roll those out as well.
Thank you. How often do you recommend the Void Saver to be pumped for proper maintenance?
It's going to follow the standard maintenance procedures that we have out there. It's when you get in there, if you're in an icing area, just get in there once a year, check it out. It's pretty easy to access these systems. The valves generally are on the other end of the sediment load outlet, so you should not see issues there with maintaining. They're head-driven, very high quality 6-inch valves that are out there, so no concerns there on longevity with relation to the system. But again, just as easy as everything else has been. Jet vacs, get in if you need, or get in by person.
Thank you, Rob. Please describe the flap valve process in the Void Saver unit. It seems like the hydrostatic pressure is the same on both the inside and outside of the unit. So what forces the valve to open into the tank to drain the Void Saver?
They're all head pressure driven valves. I'm not sure I understand the question. Can you just take notes of that? Jill, and we'll
Yes.
follow back up with that person.
Sure can. Can you design components like access ladders or internal weir plates in the DYO tool?
Yes, you can. So I won't throw it to you on this one with design stuff, but we're working on bringing the void saver components in there. Weir plates, valves, trash racks, will all be able to be dragged into these systems with just an easy, as I had shown, is adding stubs and risers, placing these in, making sure that they're right size. So do hope to have various options on storm sizes to be able to make sure that the user has the ability to make sure everything's internally is properly sized.
Thank you, Rob. How does Contech address small sites, an acre or less in area, that have shallow outlets and their underground detention systems?
Julia?
Yeah, so for shallow sites, I would, you have a challenging vertical depth cross-section profile, so we can go all the way down to small diameters. I think most of the designs that we work through in our exercises today were large diameter, but we can go down all the way to small diameter, 18-inch, 12-inch for any of those shallow profiles as well. So typically we can go as small as needed to fit those vertical sections, and then typically you add that 1 foot of minimum cover to make sure that you meet your cover requirements as well.
Thank you, Yuya. What is the life expectancy of your underground pipe materials?
Oh, that depends on the actual material type. So generally, folks will default to metal. There's actually 3 or 4 material types we offer. The main being aluminized type 2, that does have the sacrificial coating, and based on gauges and thickness, you're getting 75 plus years. And then we do have a polymeric coated material that's out there, also available in 10 through 16 gauge, I believe. And that's going to get you in that 100-year plus service life. Not used too much in underground detention. You don't have the issues that you have with bed load and stuff like that, like drainage pipe, but we do see it from time to time. And then in the coastal areas, Florida, we do offer aluminum fabrication, which is also going to get the service life there completely. Fabrication, T's, elbows, everything just the same. You'll see that a lot in the brackish, salty areas for underground storage.
Thank you, Rob. What is the cost to use your DYO tool?
Friendliness, it's free. It's you just need a Contech account. There's no payments or anything. It's all internally developed, and it's been designed to help the engineer first and foremost, communicate to the site, and then, like I had mentioned in the inner portion, work behind the scenes to make Contech more efficient with how users are doing designs.
Thank you, Rob. To prevent void contamination, is it recommended to treat runoff prior to detention? But of course, that means we have to treat a larger volume of stormwater.
Julia, your turn.
Yeah, absolutely. Any pre-treatment measure upstream of the detention system, regardless of system size or how much drainage area, especially for larger drainage areas for sure, but any detention system, whether it's above or below ground, I think it's absolutely critical to have a pre-treatment system. There's a variety of methods that you can do it with, but like a hydrodynamic separator that I previously mentioned, those are typically very small footprints, so you can put that directly upstream and have one point of spot where you can remove all the pollutants. So that's always recommended, regardless of size or how much area that it's capturing.
Thank you, Yuya. Can the software be used to calculate the required storage volume?
So I'll take this one. So typically the storage volume is predetermined, and then you enter that volume into the software. So that's how it's more or less designed. Now you can get creative. Rob showed earlier how you can maximize the storage per your given footprint. So you can highlight that option and see how much space that I have from a length and width standpoint, and then how much storage can I maximize per that given footprint. So that option is available, but then that'll obviously have to translate to your site and make sure that it works. So usually it's predetermined, but those two options within the tool is available.
Thank you, Yuya. Can the void saver be used in lieu of standard dry wells that are used in the Metro Phoenix area?
Yep, the team is looking at designs to accommodate that right now, actually.
Thank you. Do we have any other DYO tools that people can use?
Yeah, so there's a lot of legacy tools. When I say legacy, so we're looking to get everything under one platform to make it easier for everybody. But we do have our bridge division, we have our pipe division. You'll see under our DYO page all those legacy tools that I speak about, and the intent is to bring them under a single roof. But included in those are design tools, there's layout tools, there is calculators out there for storage amounts, fabric requirements, there's stormwater layout tools, there's a variety of things that are out there, and we're looking to simplify that in the next few years here upcoming.
Thank you, Rob. Are there design considerations for high groundwater in the DYODS?
Not at this time right now, Joe.
Thank you. Is it less expensive to use a 12-inch pipe for the manifold versus the full diameter pipe for the manifold?
It really depends on what the mainline pipe diameter is. So generally we advocate, if you can reduce in those larger sizes, to do so. When you get down in that size range, you're not having to flip big 5 or 8 foot sticks of pipe to fabricate T's and elbows. So it really depends on the system.
What happens when I submit a design? Are you notified?
It's the same process as before. So why it asks users if you haven't logged into the system yet, it's going to ask you for your zip code. And there's a lot of stuff that's built around that. One being it's going to tie you to the correct people for regulation and consulting support, but each zip code has a UIA equivalent. Well, UIA's title, maybe not as good as UIA, but they're going to be there as well to offer support. So they will get notified when something is created on the back end if you do export that.
Thank you, Rob. And this is our last question for today. What is the recommended minimum clearance between the top of pavement and the top of the CMP pipe?
UIA?
So that would depend on the pavement material. So whether it's classified as a rigid, if it's a rigid pavement that is sitting on top, that thickness of the pavement can be used as cover. However, if it's asphalt or some other similar flexible pavement material, then that can't be counted as part of the cover. So the minimum cover would then be defined as from the crown of the pipe to the underside of your flexible pavement.
And the DYO package does have pavement type rigid and flexible in there, and it'll adjust all the calculations on the back end to account for what's needed based on how the user dropped down between those two.
Thank you, Rob and Yuya, and thank you all for participating in today's webinar. If your question was not answered, a Contech representative will reach out to you with a response. A survey will appear once we conclude the webinar. Please complete the short survey to receive your PDH credit. A follow-up email will be sent that will include a link with instructions on how to download your PDH certificate. That concludes today's webinar. Thank you again for joining us, and have a great day.
Thanks, Jill.